Okay, so the next thing that we need to do then is begin to learn how to determine formulas from the names of ionic compounds, not just putting a couple of ions together, but if you're given a name, how do you create the ion or the formula? Okay, and this is going to require a consistent strategy and practice. Our strategy will be this. For the first step, very simply, write the atomic symbol for the cation on the left side of the formula. And again, remember, this will almost always just be an element. The rare exception is our exception, the ammonium ion. And so go ahead and do this with the list here below and on your worksheet, and then come back and click here to check to make sure that you have the right answers. We're going to go do this together though on a blank sheet here, and so all we're going to need to do again is write the symbols. So aluminum, Al, potassium, K, cesium, Cs, vanadium, V, gold, Au, tin, Sn. Ammonium is our one and only polyatomic ion, so NH4, then manganese, Mn, and cobalt, Co, and then nickel, Ni. Okay, so that's our first step. So make sure your worksheet matches that. We're not going to save that. And then again, if you weren't sure, you could go ahead and click here and you'll see an image of that. Okay? So that's our first step. The next step, leaving a little space, write the symbol for the second component after the first one. Okay? That's all you're going to do. So let's go back. And now let's add in the second thing. Okay, in this case it's fluoride. So that's just F. And then nitrate, that's polyatomic ion, ATE, right? IDE is for elements except for the two exceptions. ATE is always a polyatomic ion. In this case, NO3 is that polyatomic ion, ATE. Sulfate, SO4. Here, IDE, so it's going to be an element, right? Nitride. Chloride, an element, Cl. Hydroxide, here's one of our exceptions for IDE, and that's OH. Okay? Phosphate, ATE, PO4. IDE, oxide. Astatide, AT. And then phosphide, P. Okay? So don't be writing PO4 there. Okay, so that's our second step. So go ahead and finish that on your worksheet, and we'll get rid of that, and then we'll say that if you need to, you can go here and look and make sure that you got those same answers. Excuse me. So if the name ends in IDE, this will almost always just be a single element. Just write the atomic symbol for that. There are two exceptions to the IDE rule. Two important polyatomic ions that end in IDE are hydroxide and cyanide. You'll simply have to learn to recognize these names as being polyatomic ions rather than elements, and a clue to remembering these names will be that you can't find them on the periodic table. Okay? Now, if the names end in ATE or ITE, this will always be a polyatomic ion. So look the formula up in your list for polyatomic ions. So for the third step then, determine the charge on each ion. For the cation charge, if the metal is in an A column, you'll just go by the number of the A column. 1 plus, 2A, 2 plus, 3A, 3 plus, 4A, 4 plus, and so on. If the metal is a transition element, you're going to go to you're going to look at your name, and a Roman numeral that indicates the charge of the metal will usually be given in the name. If no Roman numeral is given, look up the element and use the most common charge. For polyatomic ions, the only positive polyatomic ion will be NH4, and its charge is 1 plus. And then for anion charges, remember the number of negative charges equals the number of electrons it would take to completely fill the valence shell. So to find this number, the easiest way is to subtract 8 from the column number 4, 5, 6, or 7. So if the anion is a polyatomic ion, look the charge up on the polyatomic ion table. Once the charge for each ion is identified, write the charge underneath the corresponding names, and then do so now for the examples above. So we'll go ahead and do that, and you can look on the sheet here as well that I've provided the link for to find that. Okay, so aluminum, it's in column 3A, so its charge is going to be 3 plus, right? Potassium is in column 1A, its charge is going to be 1 plus. Cesium is in 1A, its charge is going to be 1 plus. Vanadium, we've been told that its charge is going to be 3 plus, because that's what the Roman numeral means, right? That's the number of the charge. Gold is going to be 2 plus. Tin is going to be 4 plus. Ammonium doesn't have a Roman numeral. Oops. Not sure why I did that. But it will be 1 plus. Manganese 4 is going to be 4 plus. Cobalt 2 is going to be 2 plus, and nickel 2 is going to be 2 plus. Okay. Fluoride is in column 7A, so its charge will be -1. Nitrate's a polyatomic ion, ATE, its charge is -1. Sulfate, polyatomic ion, -2. So what am I doing here? Oh, sorry, I forgot what I was doing here. So sulfate -2. Nitride is in nitrogen's in column 5, so its charge is going to be -3. Chloride's in column 7, its charge is going to be -1. Hydroxide is one of the IDE exceptions for non-elemental polyatomic ions. That's OH. Phosphate is going to be -3. Oxide is going to be -2. Astatite is going to be -1. It's in column 7. Phosphide is going to be -3 because it's in column 5. And 5 minus 8 is -3. Okay, so that's our sheet for the third step. The fourth step. So the fourth step, we need to now determine the number of cation and anion particles necessary at each of their charges to make the total number of positive and negative charges for the formula equal, right? That's the whole goal of this. The number of positive and negative charges have to be equal. And then we use these numbers as the subscripts. Okay, so we've already been through this once. The ways to do this are as follows. If the negative number of charges for the anion already equals the number of positive charges for the cation, the formula is already balanced and you just need one of each. Neither ion gets a subscript. If the charges are not equal in value, you can multiply the numbers of the two charges together. This will give you the This will give you the total number of positive and negative charges needed to balance the formula, then determine how many of each particle is necessary to give you that many charges, and this will be the subscript for the ion. Now, a quick way to accomplish the same thing is just to switch the numbers. That's our trick, right? Switch the two numbers and use the switched numbers as subscripts. And if you do that, if one of the numbers is 1, that ion does not need a subscript. If both numbers are even, reduce the numbers to the lowest amount possible. And so complete the examples, and let's go do that. And then if you need to, click back here to check your answers. So, okay, so you can see just by inspection that you will need 3 negative ones to balance a 3, or you can just switch them and you'll have AlF3. If I get the right size line there. Okay, potassium and nitrate are already balanced, right? They have the same value, so I don't need to do anything with those subscripts. If I look at cesium sulfate, you can inspect and say that I know that I'll need 2 positive ones to balance a negative 2, or you can just switch the numbers again, right? Vanadium 3 nitride, they both are the same number, so you don't need to do anything to those. Okay, the subscripts are already equal and you don't need to add one. Gold chloride, you can see by inspection that you'll need 2 negative ones to balance a positive 2, so you can put a 2 there. So you can see by inspection that you'll need 4 negative ones to balance a 4 plus, and so remember that for a polyatomic ion you'll need to put parentheses around that, and if you don't, then it just means that the hydrogen has 4, but we want all of it to be 4. Okay, ammonium phosphate, you can see that we'll need 3 plus 1s to balance a minus 3, or again you can switch the numbers, but again remember you'll need to put a subscript there. Then manganese oxide, if I switch the numbers I'll have 2 and 4, but remember they're even, so we'll need to reduce that to its lowest denominator, and that would be 1 and 2, so MnO2. Then cobalt acetatide, you can see that you'll need 2 negative ones to balance a positive 2, and then finally nickel phosphide, you can see that we just switch the numbers here and we'll get nickel 3, phosphorus 2. Okay, so those are our formulas from names. Okay, so probably going to run out of time here before we can finish the rest of this, so let's have a 4th video. We'll go back to the presentation here. We won't save that, and again you can click to check your answers, and you can see that that allows us to do that. And we'll stop this video and then we'll go to the next one.